Hey everyone, and welcome. Today, we are going to dive deep into a concept that every single developer needs to master if they want to write seriously fast, high-performance code. We're talking about processes versus threads. What's the real difference? And more importantly, when do you use one over the other? Let's get into it.
So let's kick things off with a little puzzle. Just think about what your computer is doing right this second. You've probably got a browser open, maybe VS Code, a music app streaming, a server running. All of this on a machine that has what? 4, maybe 8 CPU cores? How is that even possible? Well, the magic behind it all lies deep inside your operating system.
So here's our game plan for today. We'll start with the computer's master conductor, the OS. Then we'll get into the main event, processes and threads. After that, we'll put them to the test in a practical showdown. And finally, we'll talk about why this is an absolute game changer for you as a developer.
All right, first things first. We can't talk about processes or threads without understanding the foundation they're built on, the operating system, or OS for short. So what is an operating system, really? You can think of it as the master conductor of your computer's orchestra. It's this super specialized piece of software that manages all the hardware, the CPU, the memory, the disk drive, and decides which one of your apps gets to use what and for how long. It's the boss.
So how does the OS create that illusion that everything is running at once? It performs a brilliant little magic trick called context switching. It gives one app, let's say app A, a tiny slice of CPU time. Then, after just a millisecond, it hits pause, saves everything app A was doing, and gives the CPU to app B. This switch happens thousands of times a second. It's so ridiculously fast that to our human eyes, it looks like everything's happening in perfect harmony, all at the same time.
Okay, so the OS has set the stage. Now let's bring out our first major player, the process.
A process is, pretty simply, just a program that's running. When you double-click Chrome or you run your code editor, you're kicking off a process. Now, the most important thing to get here, the key takeaway, is that every single process gets its very own totally isolated memory space. It's like its own little private sandbox, completely walled off from all the other processes.
But, that incredible security and isolation, it comes with a price tag. Creating that whole new sandbox for a process is actually pretty slow, and it takes up a lot of system resources. So, what if you need to do a bunch of different things inside just one application? Well, that is the perfect setup for our next actor. And that's where threads come into the picture. If processes are these big, heavy lifters, then threads are the nimble, super lightweight workers. They're the go-to solution for getting multiple things done efficiently inside a single process. A thread is the absolute smallest unit of work that your operating system can handle. The best way to think about them is like a team of specialists, all working inside the same workshop, that workshop being the process. And because they're all in the same room, they share everything, especially memory. And that is what makes creating them so incredibly fast and efficient.
Let's use an analogy here because it makes it crystal clear. A process is like a separate, standalone house. It's got its own address, its own walls, its own plumbing. It's very secure and isolated, but, building a whole new house is slow and expensive. Threads, on the other hand, are like different rooms inside that one house. They all share the same foundation and utilities, which makes adding a new room super cheap and fast. And of course, it's way easier for people to talk to each other when they're in the same house.
Okay, theory is great and all, but I want you to see the difference. Let's put these two concepts head-to-head in a real-world Node.js code challenge.
So here's our challenge. We need to run 3 CPU-intensive loops. Each one takes about 1.3 seconds to finish on its own. For our first approach, we're going to do it the simple, old-fashioned way. Just run them one after another sequentially in a single Node.js process. And the result is, well, it's exactly what you'd expect, right? About 4.1 seconds. The total time is just the sum of all the individual loops. We're totally bottlenecked here because we can only do one thing at a time.
All right, now for round 2. Let's try this again, but this time with the smarter approach. We're going to use Node.js's Worker Threads module to give each of those heavy loops its very own dedicated thread. This means they can all run in parallel at the exact same time.
And wow, just look at that difference. By using threads, we went from 4.1 seconds all the way down to just 1.7 seconds. We cut the execution time by more than half. That right there is the raw power of multi-threading in action. It's not just a small improvement, it's a massive leap in performance.
So this is all really cool, but let's bring it back home. What does this actually mean for you as a developer, especially if you're working with something like Node.js?
Now, I know what some of you are probably thinking because it's a very common point of confusion. You're thinking, hold on a second. I've heard a million times that Node.js is single-threaded, right?
Well, that's kind of old news. The truth is a bit more nuanced. While it's true that your main JavaScript code runs on a single thread called the event loop, that's not the whole story anymore. Ever since 2019, with Node version 12, we've had the worker threads module. This gives us, the developers, the power to create and manage our own threads to absolutely demolish those heavy CPU-bound tasks. So no, Node.js is not strictly single-threaded anymore.
And so all of this leaves us with a final practical question for you to take back to your own work. Now that you understand the trade-offs, the heavy-duty isolation of a process versus the fast, lightweight collaboration of a thread, when will you choose to spin up a new thread, and when do you really need the full power of a new process in your next project? Because making that choice correctly, that's the key to unlocking some serious performance in your applications.